Assalamualaikum and greetings to everyone. Welcome to my Viva presentation of Araceae in the water catchment area of Bukit Maras, Terengganu. This is the outline of my presentation. The Araceae family, commonly known as the arum family or Cladi to locals, is a diverse group of monocotyledonous flowering plants with a spreading inflorescence enclosed by pathbreadth. Found worldwide, especially in tropical regions, they occupy various habitats, including forests, rice fields, ponds, and rivers. The family is rich in species diversity, with 144 genera and 3,676 accepted species. In Peninsular Malaysia, particularly in Terengganu, Bukit Maras, limited research has been conducted on Araceae, making the study crucial for expanding knowledge on the family diversity and ecological factors influencing it. The problem lies in the significant threat posed to the Araceae family by deforestation and land use changes, particularly in Terengganu, Malaysia. The country has experienced a substantial loss of natural forests, leading to habitat destruction, a decrease in habitat quality, and the extinction of species that depend on the shaded environment. Additionally, the combination of biotic and abiotic stresses along with climate change exacerbate the negative impact on trees, including Araceae. Despite extensive research on the diversity and distribution of Araceae in Peninsular Malaysia, limited knowledge exists about the family in Terengganu. This study aims to fill this knowledge gap and provide valuable insight into the diversity and conservation of Araceae in the region. The significance of this study lies in its contribution to the understanding of Araceae population in Peninsular Malaysia, specifically Terengganu. By providing valuable data on Araceae species and their distribution in Bukit Maras, this study serves as an indicator of the forest ecosystem health and biodiversity. It will be a valuable resource for researchers interested in further studying Araceae in the region, providing them with essential reference information. Additionally, the study aims to clarify the species diversity of Araceae in Bukit Maras and investigate the importance of environmental factors that influence their distribution. This information is crucial for developing sustainable management plans, especially in an area like Bukit Maras, which is located near to human settlements and agricultural activities. Ultimately, the research will contribute to the conservation and management of Araceae family and its habitat in Terengganu. The major purpose of this study is to determine the distribution of Araceae in Bukit Maras, Terengganu. The research objectives are to determine the diversity of Araceae in the Bukit Maras, Terengganu, to determine the environmental factors of soils that affect the growth of Araceae species, and lastly, to analyze the relationship between environmental factors of soils that affect the growth of Araceae species. Araceae exhibits a diverse range of life forms, including hemiepiphytes, epiphytes, helophytes, geophytes, lithophytes, and rheophytes. Hemiepiphytes are common in humid tropical forests and can be primary or secondary, with some starting above ground and others as seedling on the forest floor. Epiphytes, found mainly in the neotropics, do not connect to the ground and include species like Anthurium and Philodendron. Helophytes are found in various taxonomic groups in both tropical and temperate regions, with stems that can be semi-prostrate, tuberous, rhizomatous, or erect. Geophytes have subterranean stems and often exhibit periodic dormant periods, with many species found in temperate latitudes. Some Araceae also grows as lithophytes on rocks, while rheophytes thrive in flood-prone areas near swiftly moving stream or river. The vegetative morphology varies among Araceae, with distinct root, stem, and leaf structure. Dimorphic roots are typical, while the stem varies from aerial elongated axis to hypogeal rhizomes or subglobose tubers. Leaves show various shapes, including sagittate, hestate, paradisect, and pinnaphid. In this study, data collection methods for Araceae plant samples were described, including their collection, height measurement, and preparation for herbarium specimens. Significant environmental factors affecting Araceae growth were identified, such as light intensity, soil moisture, soil pH, and organic matter content. Soil moisture was measured gravimetrically, soil pH was determined through the pH meter, and organic matter were assessed using the loss on ignition method. Data analysis using past software involved assessing species diversity using the Simpson Diversity Index, Shannon Diversity Index, species evenness, and marker leaf richness index. Statistical analysis using Pearson correlation coefficient was conducted using SPSS to examine the correlation between Araceae height and the environmental factors. The study conducted in Bukit Maras identified the presence of Cismatoglottis wallichii as the sole expected Araceae species, while a total of 10 species from 9 genera were recorded, encompassing 135 individual Araceae plants. The species found were Aglaonema nitidum, Alocasia longiloba, Alocasia michotitiana, Colocasia esculenta, Dieffenbachia ciguin, Homalomena species, Kiawa pericensis, Cismatoglottis wallichii, Scindapsus hederaceus, and Vietnamocasia dawe. The highest number of individual species, totaling 30, was observed for Colocasia esculenta in the lowland dipterocarp near the riverbank at 25 meter elevation. Conversely, the lowest count of individual species, with only one individual, belonged to Alocasia species in the lowland dipterocarp at 150 meter elevation. These findings provide valuable insights into the diversity and distribution of Araceae species in Bukit Maras. The table shows the estimated index value of diversity in Bukit Maras analyzed by past software. The Araceae population in the lowland dipterocarp and hill dipterocarp have a Simpson diversity index of 0.84 and 0.41 respectively. The Simpson diversity index value is higher in lowland dipterocarp, which is extremely near in the benchmark value of 1 than the hill dipterocarp. Moreover, the Shannon diversity index value in lowland dipterocarp is 1.95, while in hill dipterocarp is 0.76. This indicates that the diversity in lowland dipterocarp has higher diversity of Araceae, while hill dipterocarp has relatively low diversity of Araceae. The Shannon diversity index measures species diversity, taking into account both species richness and evenness. A higher index value indicates greater diversity and complexity in species composition. The lowland dipterocarp forest exhibited a higher Shannon diversity index, suggesting a more diverse Araceae population with a balanced distribution of species. In contrast, the hill dipterocarp forest displayed a lower index value, indicating lower species diversity and potentially uneven species abundances. The species evenness of Araceae in the lowland dipterocarp forest was calculated to be 0.78, while in the hill dipterocarp forest it was 0.71. These values indicate the degree of evenness in the distribution of Araceae species within each forest type. A higher evenness value suggests a more balanced distribution of species abundances, where no single species dominates the community. The lowland dipterocarp forest exhibited higher evenness, indicating a more equitable distribution of Araceae species compared to the hill dipterocarp forest. Lastly, in the lowland dipterocarp forest, the marker leaf richness index was recorded as 1.69, indicating higher species richness and diversity. This suggests that a wide variety of Araceae species coexist in the forest type, possibly due to favorable condition and nature diversity. In contrast, the hill dipterocarp forest shows a lower diversity index of 0.66, indicating comparatively lower. These tables shows the result of the recorded growth and environmental factors of Araceae. The figure showed the results of Pearson correlation analysis between various environmental factors and the height of Araceae species. This study examined the correlation between soil moisture, light intensity, soil pH, and organic matter content with the height of Araceae plants in Bukit Maras, Terengganu. The findings reveal both positive and negative correlation, including the potential influence of these environmental factors on Araceae height. The negative correlation between soil moisture and Araceae height, with a correlation coefficient of negative 0.1, suggests a weak and statistically non-significant inverse relationship. The small sample size of 10 might limit the ability to detect significant correlation, and caution should be applied when interpreting the results. Other environmental factors such as light intensity and nutrient content may also impact plant growth, and soil moisture alone may not be primary determinant of Araceae height in this dataset. On the other hand, there is a moderate and statistically significant positive correlation between light intensity and Araceae height. With a correlation coefficient of 0.4, this indicates that light intensity has a considerable influence of Araceae height, and changes in light levels are associated with noticeable variation in plant growth. Higher light intensity promotes photosynthesis, leading to increased production of essential compounds and enhance the plant growth height development. Araceae species exhibit phototropic responses, growing toward light sources, which contributes to their optimal growth under higher light intensity. Similarly, there is a weak but statistically significant positive correlation between soil pH and Araceae height, with a correlation coefficient of 0.11. As soil pH becomes more alkaline, Araceae height has a slight tendency to increase. This may be attributed to the influence of pH on nutrient availability, with higher pH levels promoting better nutrient uptake and supporting favorable growth conditions for Araceae plants. The most significant positive correlation is observed between organic matter content and Araceae height, with a correlation coefficient of 0.49. This indicates that organic matter substantially influences Araceae height, with increased organic matter content providing nutrient enrichment, improved soil structure, and enhanced water retention. Organic matter supports a thriving microbial community in the soil, leading to efficient nutrient cycling and increase the photosynthesis rates, promoting Araceae growth and height development. In conclusion, the Araceae species in Bukit Maras has been identified. Based on the data, 135 of total individuals of Araceae identified were from 9 genera and 10 species. The highest diversity is on the lowland dipterocarp. The study revealed the diversity of Araceae species and their association with environmental factors, specifically light intensity, soil pH, and organic matter, which significantly influence their growth of height. Understanding this relationship has implications for conservation and management efforts to preserve Araceae population and promote their development in various ecosystems. To improve the diversity and understanding of relationship between environmental factors and Araceae growth in Bukit Maras, the sample size should be increased both in Araceae population and environmental data to obtain more reliable and representative results. Long-term monitoring of Araceae population and environmental factors should be initiated to identify trends and seasonal variation. Incorporating spatial analysis will help account for spatial variability while including additional environmental factors such as soil texture, nutrient concentration, temperature, and canopy cover will provide a comprehensive understanding of their collective impact on plant height. Lastly, engaging local community will offer valuable insights, and collaborative research efforts will foster data sharing and resource pooling. By integrating these strategies, we can develop effective conservation and management plans that prioritize diverse and suitable habitats for Araceae growth and consider potential climate change impact on the region's ecology.